So let me tell you how Tinybird solves ClickHouse ingestion. This is a quote from a user this week who said, essentially, I want an endpoint where I can ingest all the data. So this is what developers have in mind. They don't have in mind like the tens of settings you need to tweak in ClickHouse, the number of things we've seen you have to take into account. Basically, what they want is an endpoint where I can ingest all the data. And this is what Tinybird just provides. So first thing you have to do, we are in ClickHouse, you need to provide your table schema, columns, data types, JSON paths, because in this case we are ingesting JSON, and your engine settings. What type of engine, the partition key, the sorting key. These are the basics. We've seen this in the previous videos. You need to learn about this when working with ClickHouse. Optionally, you can define a token which is going to have append permissions over this table. Now, you want to insert data, you have an HTTP API endpoint, events API, you provide the name of your table, you provide the token with append permissions, and you send the payload. It can be one object, it can be several objects, okay? And Tinybird handles automatically all the ingestion problems we've seen you may have in ClickHouse. It's gonna automatically batch inserts, it's gonna provide back pressure management, it's gonna take into account schema evolution. Remember, you have live data, you change the schema, you have some mutations, some backfilling that's built into the system. It automatically coordinates replica, optimizes merges, it provides logic for retrying and avoids the duplication. So let's go deep on how this works. Let me show you how Tinybird handles ingestion to ClickHouse. So this is your system, and your expectation is to send payloads to an events API. So every circle represents a payload. It might have different sizes, different number of rows, different size in megabytes, and every color means a payload for a different table. So now data gets to the events API. This is an HTTP interface that Tinybird provides that simply gathers events from your system. And those events are going to be processed by the gatherer. The gatherer is a buffer, an orchestrator between your producers and your ClickHouse cluster. Okay, this is your ClickHouse cluster. This is your system, and in the middle we have the events API and the gatherer. So what does the gatherer does? First, it provides a worker for each table that's gonna batch all the events into optimized parts. So it does not matter your throughput here, because it's gonna automatically create per partition ingestion, so less CPU is going to be used in your ClickHouse cluster, and you're not going to have the too many parts problem. Now, it comes with automatic back pressure mechanism because it's constantly monitoring CPU and memory of the ClickHouse cluster. So whenever there is some server overloaded, it's gonna automatically delay flashes or enable some circuit breaker for several seconds or a minute, depending on the CPU load. On the other hand, it also monitors memory, because when you insert into a table in ClickHouse, you may have downstream materialized views, or you might have another process running on the same server, let's say a mutation, a backfill operation, and it can do several things. It can unlink an offending materialized view that's not optimized. It can increase the number of threads to process the inserts, or again, it can delay the flush to the system. It automatically implements routing. So for instance, you may have separate tables writing into different ClickHouse replicas. This is automatic. And it also implements failover mechanisms. So let's say you are ingesting this orange table into this replica, and suddenly this replica goes down. What's gonna happen is it automatically going to route to a different replica, and it's gonna automatically retry the parts it has in the buffer with a deduplication window. Last resort, if the cluster is completely unhealthy, there is a dead letter queue, which is basically going to write all the parts to S3 so they can be eventually replied. So you're not gonna lose data. It's gonna handle retries with the duplication. It's gonna batch inserts, and it's gonna implement back pressure mechanisms while monitoring your cluster health, plus adding proper routing for to the most healthy replicas. Let's see how this works in practice. I'm going to open Tinybird code, and we're gonna create a new workspace for a fleet management system. And I'm gonna ask Tinybird code to create a data source for a fleet management system. So this is going to create a table with schema, with our columns, a timestamp, a vehicle ID, driver ID, a position, speed, etc., etc. It's going to be a merge tree, partition by month, and order by vehicle and timestamp. That's good. Now I'm going to deploy the schema to the cloud. And if we take a look at the data source that we just created, we have a fleet events here, and we have a button to ingest data. I'm gonna click it, and this is how you use the events API for this specific data source. So from the point of view of a developer, I just have to worry about creating the schema, defining the proper engine, partition and sorting key, and then start sending events from my system. So let's see an example. I'm going to copy this, and if I run it from the terminal, we're gonna see we've ingested one row. We can do this as many times as we want, and we can even try to send thousands of events per second. Let's try to do it. So we can save, for instance, the payload in a JSON file, and we can use Apache Bench to send 10,000 requests in batches of 1,000 records. And I don't have to worry about anything else. I just have to send my events to the API. And as we have seen, the gatherer is going to batch the right parts. It's going to buffer them. It's going to flash them to the proper ClickHouse replica, and I don't have to care about any of the settings that manage ingestion in ClickHouse. And if I run an SQL over the fleet events table, we see we have there our data.